Welcome, everybody, to another episode of Be Brown Bag. I have the pleasure today to introduce Mike Foley at Mike Foley in Twitter, who is going to give you an update on vSphere 6.7 security features. Just some things we get out of the way. You can get in on the conversation, especially with the hashtag #BeBrownBag, or you can ping the local accounts for each one of our shows. We're worldwide. We cover several languages and several days. You can just use the GoToMeeting question feature, and I'll interrupt Mike whenever I can to ask him a question. Um, I'm your host, Ariel Sanchez, and I'm going to send over control to Mike, and he can introduce himself. So, Mike, take it away.
All righty. Let me just tweet that out, and we're good. Okay, we are live from Shedquarters in Hubbardston, Massachusetts. I know everyone asks where the hell is Hubbardston.
I'm only seeing. No, I'm only seeing black so far.
Oh my God! Come on. Let me stop sharing the screen. And what the hell's the share screen thing? Show Microsoft PowerPoint. You should be seeing it now.
Perfect.
Okay, now we can start. Technical difficulties. Who said I was an engineer? Okay, my name is Mike Foley, and we are live from Shedquarters in Hubbardston, Massachusetts. That is in north central Massachusetts, and there you can see my home office, also known as Shedquarters. Today we will be talking about vSphere 6.7 security with yours truly, and let's dive into it. So what we will be talking about first is Trusted Platform Module TPM 2.0 used by ESX to test the hypervisor. And then we'll dive into Windows 10 and Windows Server 2016 security features. These are technically known as support for virtualization-based security, also known as VBS. But your security guy doesn't know what VBS is. He's going to be asking you, begging you, pleading you, and demanding that you support Credential Guard. And that's what this is all about. We will also be talking about virtualized TPM 2.0. This is secured with VM encryption. I'll go into more details later. Some of the new UI enhancements around VM encryption. We'll talk about FIPS 140-2 crypto, TLS 1.2 on by default, and then we'll finish up with some of the new alarms and why they are there. I'll also talk about a number of different blogs that I've done. You can see them at yelof.com or blogs.vmware.com/vsphere and search for Foley. So ESX and TPM 2.0, I am actually writing 2 new blog articles in support of this. There's already the introduction to vSphere 6.7 security out there already, and there is an article that goes over how ESXi uses TPM 2.0, and then the new blog articles that I'm hoping to release very, very shortly. There will be one on how to prepare your ESX host to use Secure Boot, and then one on how to configure TPM 2.0 in the BIOS and some of the troubleshooting things that I went through when I set up my servers. So when we talk about TPM 2.0, we're really talking about the establishment of a hardware root of trust. And what we use TPM 2.0 for is to validate that Secure Boot has done its job. Now, Secure Boot was introduced in 6.5 for ESXi, and what it does is it validates the bootloader, the kernel, and then all of the VIBs that comprised ESXi. So here we have an ESXi host with a TPM 2.0 chip. The chip can store credentials it can also store measurements. Now, one thing about a TPM is it cannot store a whole bunch of stuff. It cannot store certificates for 5,000 users or certificates for 500 VMs. So the amount of storage that a TPM has is measured in kilobytes. Let me rephrase that, kilobytes. So what we're going to use the TPM for ESXi is to store measurements. So when you boot, the UEFI firmware validates the ESXi bootloader. And then and what that does is there's a digital certificate, I believe it's a Microsoft digital certificate, that is stored in the UEFI firmware. It's not provided by VMware, that's why it's blue. And the UEFI firmware is smart enough, it's actually a whole OS all unto itself, is actually smart enough to validate the digital signature of the bootloader. So if your system was rooted, then the bootloader signature would be invalid and the bootloader would not chain to the digital certificate in the UEFI firmware, and the UEFI firmware would not let you boot. So UEFI validates the bootloader. Within the bootloader is another digital certificate, and that digital certificate is a VMware digital certificate. That's why it's green. So the bootloader is now smart enough to validate the kernel. So now we have a bootloader validated by firmware, and then a kernel validated by a validated bootloader. And at this point, measurements are written to the TPM. Now, these are hash values. So these measurements are written to the TPM, and vCenter will get those measurements later. Secure Boot continues on its way. So the Secure Boot verifier has a digital certificate, and then it validates all of the vSphere installation bundles that comprise ESXi. Excuse me. One thing to note, when I wrote those hash values to the TPM, one of those hash values was Secure Boot enabled. So we're querying at the BIOS or the firmware level, was Secure Boot turned on? So now I have a running ESXi host. vCenter comes along and pulls host event log data and VIB metadata from the running ESXi host, creates hash values, pulls the hash values out of the TPM, and compares them. And if the hash values match, then the host is marked as having passed attestation. So that gives you not only the assurance that that Secure Boot has run, but a out-of-band assurance that everything was correct, that Secure Boot ran. This is all then rolled up into a security report within the cluster. So you'll see in the cluster that all 4 of my ESXi hosts have TPM 2.0 and have passed attestation. And my blog articles will go into how I got that to actually happen. And some of those blog articles will talk about some of the purple screens of death I got around trying to enable Secure Boot and then how to work through all of those things. The next thing we're going to talk about is Windows 10 and Windows 2016 security features support.
And Mike, just before you delve into that,
yeah.
I have a couple questions, kind of related.
Okay.
And I think I'm right in saying that. Are
they showing up in the questions thing, or are these questions from you?
No, they're showing up in the questions thing. They're from Graham.
I'm not seeing any.
Oh, I can upgrade you so you can see them.
Oh yeah, okay, that would help an awful lot because I'd rather answer them while I'm going through this.
Yeah, hold on. All right, you should have a lot more options now, and you should be able to see them and my answers.
I'm not seeing any questions.
I can also assign them to you. Hold on. Question to Mike Foley. Assign question to Mike Foley. Assign question to Mike Foley. I don't know if that helps.
I'm still not seeing anything.
Not helpful. Anyways, I'll just tell them. Yeah. So can servers with old TPM be upgraded to 2.0? I believe that's a no.
That's a great question for your server vendor.
Mm-hmm.
Right? So I have some Dell D630s in my lab, and they came with TPM 1.2. There is a Dell kit that allows you to upgrade them to TPM 2.0, and it worked just fine.
Okay.
So that is a question for your server vendor.
And the other question was, does this in any way relate to the software acceptance level, like community and third-party VIBs, or is it a separate process completely?
Absolutely it does. So remember, what we're talking about, let me go back a slide. What we're talking about is secure boot. So what we're really doing is we're validating that secure boot worked. And with secure boot turned on, you can only have signed VIBs. So community supported VIBs would not work in this situation.
Okay. And let me know if you're able to see the questions now. I think I had missed one thing to confirm.
Still not seeing them.
That's weird.
Yeah. Yeah, I popped the Q&A window into a separate window and nothing.
It should say questions.
Yeah, it says questions up top, and I'm not. Oh, here we go. I clicked on show answered questions.
There we go.
Oh, can I? Yeah, here we go. Now I have them all.
Awesome.
And Graham Mitchell, you're a wise guy. So let me go back to what I was saying about secure boot. All the same rules apply with secure boot. TPM is just there to validate that it was set. If that makes sense.
Awesome. Thank you.
Okay. All right. Any new security key providers supported in 6.7? I'm assuming you're talking about key management. If you look in the HCL, if you search for vSphere HCL KMS, you will see a whole list of key manager providers. And I believe recently we have added an additional one or two. There's quite a number of them available now. So yeah, does that put an end to community and third-party VIBs? Secure boot puts an end to community and third-party VIBs. If you want to turn on secure boot, run only signed VIBs and run and have no ability for someone to install an unsigned VIB, then you turn on secure boot. And then you use TPM 2.0 to provide that report that secure boot worked. That's essentially what that's doing. Make sense?
Makes sense to me.
That's all I need. If it makes sense to you, Ariel, I'm good. Okay, good. I'm glad it makes sense to Graham too. So, Windows 10, Windows 2016 security features. Typically, as I mentioned earlier, your security professional will not know anything about how it works. They will not know anything about that it requires virtualization. All they care about is, can I turn on Credential Guard? And with the Windows 10, Windows 2016 security features in vSphere 6.7, yes, you can turn on Credential Guard. You can turn on all the guards. So let me start by explaining what VBS is first. And I'm going to start by having a bare metal installation. So this could be your laptop running Windows, right? The bare metal hardware has the ability to enable virtualization, has a TPM 2.0 device, and that's used typically to support BitLocker. You've installed Windows 10, you've used either standard MBR BIOS or UEFI BIOS. VBS is not enabled, no Credential Guard. When you enable VBS, then the bare metal hardware is providing virtualization support to the Windows hypervisor that is now the first thing that boots. So if I go back one, Windows is booting natively. With VBS, Windows hypervisor boots, and then Windows 10 boots. Of course, it all looks seamless, you know, in front of pretty pictures, but behind the scenes, that's what's going on. Now, in order to enable VBS, I have to have virtualization support in my CPU and IOMMU support my CPU. I have to use Secure Boot, which mandates that I have to use UEFI as the BIOS firmware. And I have to have a physical TPM. So when the Windows hypervisor boots, Windows 10 boots, and then all of the stuff that manages the credentials, lsass.exe essentially, that is now all in a separate, I don't want to use the term micro VM because that has other connotations, but what they're doing is they're leveraging virtualization to be able to run the credential subsystem in another secure separate memory space from Windows 10. And then Windows 10 speaks to that credential subsystem over a private RPC channel via the Windows hypervisor, not unlike VMCI of many, many years ago. So now Windows can say, okay, give me the credentials for Mike Foley, and if I don't have the privileges to get those credentials, I don't get them. Whereas before, the credentials were running in the same context as Windows 10, and now I could theoretically execute a pass the hash attack, where I've gotten the hashed Active Directory credentials, and I replay those back to Active Directory, and I log in as whose ever credentials I've stolen. So that's what VBS does at a physical level on bare metal. So how do we then translate that to running on top of ESXi? So if I have a standard Windows VM running on ESXi today, it's booting via MBR or EFI, and it has no Credential Guard support. When I check the box for VBS for that VM, then nested virtualization is turned on. IOMMU support is exposed to that VM. EFI firmware is set for that VM. Secure Boot is turned on for that VM. And I can optionally add a virtual TPM for that VM. VBS will work without a TPM. The TPM is used to further secure the credentials that are living in the credential subsystem. Does that give us protection against Mimikatz? That's a great question to ask Microsoft. Because look, at the end of the day, what we're really talking about here is providing to Windows all of the necessary hardware, whether it's virtual or physical, all of the necessary hardware in order for them to run with VBS enabled and for them to run with a TPM. Once we've exposed all of that, what happens in the VM now is a Microsoft question. Can 2016 VMs built on 6.5 be upgraded to turn on VBS in 6.7? Yes. What you have to do is you have to update the hardware, the virtual hardware level of that Windows 2016 VM, and at that stage you will have the ability to turn on VBS at the hypervisor level. And remember, when we say turn on VBS at the hypervisor level, that just means enable all of the stuff that Windows needs in order to turn on VBS at the guest OS level. Two separate functions. So one thing you'll see here is that when we create a virtual TPM, we secure that TPM with VM encryption, and I'll go into detail on that in a moment. But what we do not do is map that virtual TPM or chain that virtual TPM to the physical TPM. Remember when I said that a physical TPM has space measured in kilobytes? If Windows was going to be using a TPM as a TPM and mapped it to a physical TPM, what happens when I have hundreds of these virtual machines running on top of that server? Remember that a physical TPM actually lives on the serial bus. It is slow. I would have to write some type of multiplexer in order to be able to read and write to that TPM by each physical VM. That's not going to happen. The space is kilobytes. That would limit how many VMs you would have to run. And then what happens when you do a vMotion? A TPM also does cryptographic operations, but how do you then schedule all of those crypto operations across all VMs to a physical TPM? So when you start thinking about how you manage your environment, mapping to a physical TPM would bind you to a single host and limit how many VMs you could run, and you would need support within ESX to be able to multiplex all of the different requests. It's far easier for us to create a virtual TPM that provides all of that functionality. And instead of securing that with a physical device, meaning the TPM, we secure that with VM encryption. So to enable VBS within the VM options for that VM is one checkbox. Now, mind you, if you have installed, back to the Can Windows 2016 VMs be upgraded, if you have installed Windows 2016 or Windows 10 using a standard BIOS or the master boot record BIOS and not UEFI, or within the VM options, it's EFI, you're going to have to do some things within the guest OS to enable that VM to be booted using UEFI. That's outside of the scope of what we would do for you. That's a guest OS operation. So assuming you've installed it with the EFI, this is going to ensure that EFI is the BIOS selected. It's going to enable secure boot, and it's going to turn on IOMMU and hardware virtualization. You probably noticed in 6.7 that we dropped support for a number of older CPUs. by moving away from binary translation and using more and more of the CPU hardware virtualization support. This is one of those things that that really takes advantage of the hardware virtualization support and the ability to do multiple address tables and so forth. To add a virtual machine is as simple as just adding a new device. When I add that new device, then the virtual machine's home files, parts of the VMX, the NVRAM file, swap file, etc., those files will now be encrypted using VM encryption. So in order to turn on or use virtual TPM, you need to have a third-party key manager and have the ability to enable VM encryption. So then the question always shows up is, so does this mean I can run BitLocker within my virtual machine? Technically, you could, but it would make more sense seeing as how you already have all of the infrastructure in place to run VM encryption to just use VM encryption and not have to deal with encrypting within a guest. But hey, you know, if you're a sadist, then knock yourself out. If you want to encrypt all of those VMDKs that in this environment where we're talking about just virtual TPM, if you want to encrypt the VMDKs, that would be considered an optional thing. So now within the guest. So in order to turn on VBS within the guest, I can do that umpteen different ways. I can use group policies. I can use the, Microsoft has a really cool PowerShell script, their readiness tool, which will turn on and do all of the right things on a per VM basis. If you're talking of, you know, having a bunch of virtual machines, you may want to do all of this via group policy. I'm not going to tell you which one is best. That's a question you have for Microsoft for your environment. If I look into Device Manager and look at that TPM device, you'll see that it just shows up as a normal TPM 2.0 device. There's no additional drivers necessary in order to support this. If I look at the properties, standard Windows drivers. Nothing special, nothing new. Part of enabling VBS is enabling Hyper-V. As I mentioned, that readiness tool, the PowerShell script, will do that for you. Also, GPO settings would do that as well. So really, when I say booting the Microsoft Hypervisor, you are booting Hyper-V. So all VMs that have VBS enabled are nested VMs. And as most of you listen to the podcast know, VMware has a huge lead in managing and running nested virtualization. Just look at our hands-on lab. So to secure that virtual TPM data, let me first talk about a hardware TPM. A hardware TPM does crypto, and a hardware TPM stores sensitive data. In order to do that, the TPM needs a unique identity. When you get your laptop from your laptop vendor, and it has a TPM 2.0 chip in it, the vendor that created the TPM 2.0 chip installed in that chip a key pair that is used to provide a unique identity for that TPM. That way, the TPM can sign something with its key, and you will know that whatever that was signed came from that TPM, because only that TPM would be able to unlock it. So how do we do all of those sorts of things with a virtual TPM and then also secure the data that in a hardware TPM goes into a hardware vault, but in a virtual TPM, where do we put it? So we have VM encryption, we have a virtualized TPM, and to provide that virtualized TPM with a unique identity, a digital certificate pair is installed for that TPM. Now, that CA cert comes from VMCA. It doesn't necessarily chain to VMCA. You could certainly look at the CA, the cert that's installed for the TPM and say, I want to validate that that cert is real by using the CA cert of VMCA to do that. But what if I move that VM to another host or to another cluster somewhere and everything else? That, for some people, that might be an issue. For most, a VMCA cert will be fine. We just came out with some things up on GitHub, some PowerShell commandlets we'd really like you to try out that allow you to install your own digital certificates. So if you want to mint your own digital certificate from your own CA, you can use that cert as the signing cert within the virtual TPM. And there are commandlets that allow you to do that. You can also do it via the UI. So all of the data that's written to that virtual TPM, also in kilobytes, is written to the NVRAM file. And the NVRAM file is encrypted. Now, what this gives you, by using VM encryption, all of the rules for VM encryption still apply. Meaning, if I have a major disaster in my site, and all I'm left with is a disk array full of VMs and no vCenter, I only have to create a new vCenter, map it to the existing key manager infrastructure, because you read my topology blog on KMS servers, map it to the key management infrastructure, and I can register all of those VMs, and now I can just power them on. So from an IT operations standpoint, I still retain a huge amount of flexibility, a huge amount of capability from a disaster recovery standpoint, or even just I want to move this VM from site A to site B, while still providing a lot of security at the virtual machine level. So here's that screen within the UI that allows you to replace those digital certificates that are used for signing. And as I mentioned, there are some commandlets that are currently up on GitHub that you can try and provide your feedback to the engineers on that. The virtual machine takeaways does not map, nor does it require a hardware TPM. Does require VM encryption and a third-party KMS. Excuse me. Virtual machines are provided with trusted virtual hardware, and then trusted virtual hardware is presented to VMs by the host. The ESXi host has a root of trust to the physical hardware, and the VTPM uniqueness is established by those digital certificates. Any questions on virtual TPM? Okay, is there any API for NVRAM? Our build process, let me make that question bigger. Our build process copies a standard golden NVRAM, which presumably won't work when encrypted. There's no API for NVRAM. If you have not encrypted that golden NVRAM, meaning I'm assuming it's is it a file or is it attached to a VM, or you've created it and then copied that NVRAM? once you enable VBS, that NVRAM would become encrypted. So if it's working today, so yeah, you create then copy, it should work. Let me know if it doesn't. All right, it's Graham with all the questions tonight. So within the H5 UI, we've modified some of the look and feel of how to manage encryption. So we're really going towards trying to make it as easy to manage as possible. There's now an encryption section, and in there is where you would set encryption for that VM and also set encrypted vMotion. So all encryption is under one banner. If you drop down there, you will see all of the disks that are attached to a virtual machine, and you can select whether or not you want to encrypt a per disk, each disk attached to that VM. You could do this prior with the Power CLI modules for VM encryption, but now we're exposing that within the UI. One of the new logging features in 6.7 is you can now configure syslog targets. You can now configure up to 3 different syslog targets. So if you're an environment that says, I want syslog to go to log insight, and the security people are like, look, we don't want logs coming from log insight. We want the native logs. You can now configure one for log insight and one for whatever logging solution the security people are using. Other security features, and we're coming near the end, is FIPS 140-2. So a lot of people say, does this mean vSphere is FIPS 140-2 certified? No software-only solution gets the certified banner. What this is all of the crypto modules, so the kernel crypto, the OpenSSL module, and a Java module have all gone through FIPS validation. FIPS certified is when you say, okay, I'm going to take this hardware box, this software, these devices, create a solution, and submit that for FIPS certification, which then also means you can't change any part of that configuration without losing FIPS certification, including and up to patching, which makes absolutely no security sense, regardless. What we have here are all of the VM kernel module, which does VM and vSAN encryption. FIPS 140-2 crypto is enabled by default. Same with OpenSSL, meaning managing all of the management interfaces and creating the encrypted vMotion key. Excuse me. And then the Java module in VMCA is used for signing certificates. And then SSH is also FIPS 140-2. So we've met quite a bit of requirements with this effort here. This is like really, really serious coding going on. TLS 1.2 is on by default, and only key managers that support TLS 1.2 will be supported. If you have a key manager that doesn't support TLS 1.2, okay. And finally, there are a number of new alarms that are there, and you'll see virtual machine locked, host requires encryption mode, KMS client and server certificate status. These 3 alarms are primarily KMS. So if you got virtual machine locked, it meant you tried to power on a VM and the KMS was not available. The VM now goes into a locked state. If you wanted to power on a VM and the host does not have a encryption mode enabled, it's not set in crypto mode, you would get an alarm that says host requires encryption mode if the KMS is not available. And then obviously KMS client and server certificate status alarms. All of the blogs that I've been writing so far on vSphere 6.7 are referenced in this blog article. The vSphere 6.7 security media resources. In there, you'll see links to a bunch of Lightboard videos that I did with a migraine headache. You will see a link to the Virtually Speaking podcast, and you will see a link to a vSphere Security Ask Me Anything that I did a number of weeks ago. So there's a huge amount of resources, plus you'll see all of the links to all of the other vSphere 6.7 security blogs that are on both my website and the vSphere website.
Very cool.
That's what I have. So any KMS you can suggest for home labs that doesn't cost dollars. Answer after recording if you don't want to go on record. Nah, hell, I'll go on record. Right now, the only one I know of that you can do with no dollars if you are a home labber, and even if you're one of those people that doesn't believe in paying for supported software and you're going to run it in production anyway, is HITRUST. If you go to hitrust.com, you can get a copy of their, you have to fill out some stuff, obviously. It's not you know, free as in take a cookie. It's, they're going to want your name. But you can get up to 2 KMS servers that replicate keys between each other, and you can set that up in a home lab environment, and it works quite well. So check out the HITRUST folks. If you're talking about production level KMS servers, and I get this question all the time, Mike, what would you recommend for my customer for a KMS server? What works best with vSphere? I'm going to tell you, I'm not going to tell you because that would be the same as me saying, Mike, you asking me, Mike, what server do you recommend, or what network card do you recommend? Yeah, I don't go down that route. I'm Scottish, so no dollars are always good. Well, I'm Irish, but I really don't care. I'm in marketing. I spend money. So any other questions? Do you have any questions, Ariel?
No, I don't. Honestly, it was a very well-made presentation. It didn't feel like it took a lot of time, but here we are at the end. I really appreciate you taking the time to share this with the community, Mike.
Alrighty, no problem. Hope it helps. And I will add this, once you send me the link, I will add this to that media resources blog article.
Sounds good. Well, everybody, we're stopping the recording here. See you next week.
All right, take care.